the topic is visible smart impact assisted construction for safe space colonization. So it's first of all, it's about Mars mission, but secondly, it's for many other applications could be the same. So the idea was very simple, that real Mars mission is coming shortly, but the shelters still not ready. There are a lot of great concepts for shelters, for housing there, but most of these concepts require a lot of time, high budget, and I'm not sure that it should be in the same mission, should be separate construction mission to build it, and then should be the second with people. So it could be extended for tens of years. So the idea was to maximum use and recover energy and to use existing technologies. And usually the best technologies are military technologies. So if you'll go ahead with that, first of all, there are a lot of natural spaces underground that could be used for people because it's perfect protection there from major hazards like radiation, small sky bodies, meteorites, and earthquakes, so everything. But there are still no visible way to access these natural caves and cavities and so on. So if I'll like miss few slides there, probably I'll return back. So this about expedition, about viewing like future of that, because looks like we are looking for Mars expedition. It's not the last. It's something in the middle, at least. And Mars could be considered like the transportation hub. And I'll stop later to this point. Now I'll go to military technology. So it's very bold and simple. There are a lot of military prototypes for penetration to the deep underground. And it's beginning like 80 years ago, Disney bomb. It's already was technology that could be used for that. There are a few military options. What is unusual that it's usually designed for killing, for murdering, for destruction of bunkers, and we can reverse, we'll change the goal, we'll use it for construction instead of destruction. And we have like a lot of resources to do that. Beginning from this science of murdering, of killing, that allows to provide calculations, computing, simulations of such type of instruments, I would say. So further, I'll name it instruments. It will not be like killing projectiles anymore. It will be not bunker busters. It will be bunker construction instruments. So it could penetrate everything, steel, rock, and and it's compact. Again, it's very well developed, and probably 90% of cost could be saved using the existing level of such type bunker busters. So let me go to the next slide. There are examples of that. Because of shortage of time, I will talk about 2 or 3 major tools that could be done, and the rest probably will be presented at a different type. So this is one of these based on satellite. It's with very nice named rods from God. This purely kinetic weapon without any explosives, without just usage energy of on orbit satellite loaded with these types of rods. And the rod, when it's reaching the Earth, has like terrible destruction energy, and it's not just coming through hard like steel and rock. Everything is provided even evaporation. Sometimes it's done from tungsten because it's like very hard and high density metal. Like about this type of munition doesn't contain explosive payloads and uses just kinetic energy to penetrate the target. So, and this again, it's very schematically. It's connected to the descending vehicle, to the lander, and this set of such rods. And in our cases, there are a lot of functions that could be implemented with such simple rods. It could be in the future structure on the ground of Mars. It could be columns, it could be supports, it could be special probes for geostructural research. Again, it requires probably separate presentation, but it's easy could be converted to such type of devices. And on the high velocity, it will be reach of the Earth and penetrate deep enough to be installed like major structure component. So this type of component that it's for separation of the main stage of the vehicle that will be landed, and the set of these tools. And each of these tools should be separated. The trick is it should be separated with the internal driver. It could be any of them that it fits like our requirements. But when it's internal, it will add kinetic energy. And the idea is when on the landing of the landing vehicle, it will be gradually transfer energy to these components. And it means that kinetic energy of the space vehicle, that it's very high, it could be like more than 10 kilometers per second velocity. And this energy will not be dissipated. It will be used for further like movement of the accelerated tools. And let me find I had like diagram there for that. So this example of existing bombs, it's this railgun internal drive launcher that will be incorporated between the kinetic rods and tools and the major vehicle. And this, I would say, ancient Disney bomb that anyway, it's very powerful. This again, the magnetic space launcher drives like rail gun style, but it could be any, it could be solid propellant, could be electromagnetic, could be even a light gas gun, despite probably it will not be like this. So this diagram, how it works schematically, conversion of the energy. Maybe this is better, it's some text here, fonts also. So this assembly of the vehicle with the tools attached. In certain moment, it will shoot out impact tool 1 here. So after it will shoot up, according to conservation of moment and of energy, the impact tool will increase velocity and the vehicle will reduce. Then next tool will be shoot down, and again a reduction of the velocity. And after all of this axle of velocity there, it will be at low velocity, will be like soft landed. In last moment, we still could use, of course, traditional engine, but it will be much lower velocity. Theoretically, it could be 0, but it will not, of course. So this conversion of this road system. And the bomb system, there are a lot of bombs, starting from the ancient Disney bomb, and then with nuclear heads that provide much better underground work, but it could be certain precautions should be done on that. Here, just what I'm talking, more detail, like description of the process. Due to our shortage of time, I am I'll cut presentation. This again, Disney bomb. This history of the bomb and power of this bomb with much less velocity. We have here a huge velocity there in our case. It even could not be compared with the Second War, but despite all that, it was a very good job there done with these bombs. So this just together, it's like natural lava tube, as it used to be, and this after our penetration. With penetration, I would say, device. We have this pit, we have, and it could be used for everything. For instance, examples how it's, we shoot also column of this crane. It also came with our expedition ahead of the landing. And this crane could be used for operation for cargoes to the pit and people, and could be installed like everything what we need, like any types of rods, cable rod, we could install so major components of any structural design. So here is how it could be constructed, the infrastructure. It will be gateways to the surface, planet surface, and will combine ancient natural craters and lava tubes, caves, and could create huge vast spaces for any infrastructure that we will need there. And again, it will be done. Most of the job will be done in seconds, still in advance before landing. And here it's like traditional directions of activity. Now again, I will not spend time on that.
So Leo, this is Rennie. We just have 5 minutes left. Just so
yeah,
you know.
yeah. I see. I'm accelerating already, like Disney bomb. So there are criteria of selection for such technology. What will be the best to provide artificial craters and pits. There are a lot extensive database of craters now, that 600,000 of them, and some of them are double. And hypothetically, it will be more weak ground after they hit even one asteroid. If it was twice in the same place, probably the best site for construction, and so there. Here it's example how such a pit could be used for protected launch pad. It could be placed there in this hole. Here it's similar design, but protected on the top with a kind of huge lens that it's water ice. There it's provide much more functions. I could not stop again on that because we don't have a time. So not just protection of radiation, it will be also light concentration and for energy system, for hydrogen production. There is the description of that, what it could be done with this ice on this type of the lens. So this our viewing of the future of the technology. So again, Mars could be become a hub, transportation hub between Earth and the universe. Like when very close vicinity, there are more than 1 million asteroids that come in very close to, and this technology could be used, the described technology, for further development of asteroids and for transformation into giant space vehicles. It could be even unlimited number of people, and if it will be used, like Mars could be used for like a huge space shop for production of that, its capacity will be much more than million. It's unlimited capacity practically, and it's without, and energy could be found in the same asteroids, and I don't see this slide. In the same asteroids and comets, a lot of water, and water will have deuterium. It will be nuclear power propulsion system that will be used everything from the same asteroid. So we will not need to load almost nothing there, just to provide this upgrade of simple asteroid to microplanet on that. Again, using the same similar impact technology. So, yeah, we still have a few minutes, yeah?
Yeah, so we probably have time for one or maybe two quick questions.
Yeah.
But anybody got any questions? You can either type them into the chat, or at this point, since we've only got a minute or two, you could unmute yourself and just ask the question.
Okay. So the questions?
Yeah,
I have a question.
Sure, go ahead.
If you launch this into a glacier, would it melt the ice under the ground and let it escape as steam, or would the shock wave just be dissipated and crumble the ice?
If it's in the ground?
If you launch into a glacier.
Mm-hmm. Yeah, I understand. It's a good question. It's too many factors of that. If it's very sharp and thin, probably it will be penetrated deeper. As in this first case, if it's like very white, it's probably will be evaporated, of course. Not just ice will be evaporated, even stones could be evaporated with such high energy. Again, we could control it, and we could get these like arrows, I would say, thin tools could be could have instrumentation for exploration. And on the approaching, the computer system will receive already data on the properties of the ground, and it will be small piece of avionics, and it still will have opportunity to change a little bit the site and to find what we will find is optimum. The same energy of collision also could be controlled, and with respect to your question, to prevent, for instance, explosion, if you don't need it. If you need to have very deep and wide, maybe such kind of phase transfer will be helpful. We will not need in most of the cases any nuclear or thermonuclear heads. the pure mechanical energy will be sufficient in most of the cases. And again, I'll repeat that the most beneficial, that this could be done fast because the technology is military, it's ready. And it's for construction, it does requires, and inside of this spaces that we'll release, we could place traditionally perfect systems like 3D printed, inflatable, that will provide more comfort and will be double or triple protected from external fields, nuclear radiation, and so all these hazards. So it's compatible to every technology.
So Leo, we are past our time. I appreciate you doing your presentation and getting it going for us. And thanks everyone for joining. We're going to shut her down.
Thank you very much for your attention, and sorry something happening today, maybe magnetic storm.
Thanks, Leo. Appreciate it.
Appreciate it. Thanks for the opportunity to
Sure.
to